So one common way to think about calculating margin of error is to think about our normal distribution and think about um, what values fall 2 standard deviations or standard errors above the mean and below the mean. Those two numbers would make up or consist of a confidence interval between this number, and we would then say we're 95% confident. So if our margin of error is dependent upon the standard error, then we need to do calculations on the standard error. That's what we need to do. And that's going to be, to calculate standard, that's going to be, again, based on our level of confidence. Now, if we want to be more confident with our estimate, then what happens is we need a wider margin of error. We need an interval that's wider. If we're less confident, then actually we'll have a smaller margin of error. So sometimes it can be confusing. Now, in order to determine how many standard errors above and below we want to be to calculate this margin of error, right? Again, we have to come up with some process. This value that we come up with in the process is called what's called a critical value, right there. And we'll show you how to calculate that. Margin of error, the E, right? That big E is the critical value. It's called a critical Z score for when we're looking at a confidence interval proportion times the standard error from the sample data we have. So, what is a critical value? Well, when we look at this idea of critical Z score, right? We're going to be talking about proportions in this case, and we think about just the general idea. 25 between if I have estimate about something between 25 and 35 versus 20 and 40%. I'm actually more confident the wider that this actually will contain the correct answer, right? The proportion of people 25 and over have a college degree, right? Which one is more likely to be correct? I'm more confident on this one because it's wider. This is smaller, so I'd be less confident. Now, what is confidence? The confidence level of our estimate represents the percentage of time that our sample data will give us an interval estimate that contains the parameter, meaning that we're actually trying to determine the value for the population. And when we do a calculation, right, at a certain level of confidence, that's what this level of confidence means. That when I do this calculation, this percentage of the time the interval will have the population parameter inside of it, or the population parameter will be inside of that interval. So it's important to think about that. Now, if we look at the different Z-scores, we're going to end up looking at what's called here critical Z-scores. And how do I determine the critical Z-scores with respect to the level of confidence? Now, remember, to calculate margin of error, it's your critical value times the standard error. So suppose we want to be 95% confident, then our Z-score is going to be 1.96. If we want to be 99% confident, then our critical Z is 2.574. It's a bigger value, which would give us a wider interval. Remember, because it's critical Z times the standard error. So the bigger the value, the wider. So I'm more confident, the bigger Z. Now, we're going to use the ARTISTAT to calculate that, or you're going to remember some common critical Z values. These are probably the most common confidence intervals and levels of confidence we have. 1.645, 1.96, 2.576. Those are the most common ones we use. Now, how would I get 90? If I want to be 92% confident, what would I do? I'll show you how we get 1.751. So to calculate that critical Z, we're going to have those instructions at the top of our notes. We want to find the percentile. We're going to use critical Z, so it's a standard normal distribution. And what we're looking at is I want to be 92% confident. So what you do is you turn this number into 92. And what we're doing is a two-tailed. So if you notice, that's where we get the, 92. I need to put 92 in there. There it is. And then you get the 1.751 and 1 point, negative and positive. This is the kind of the middle. This is that confidence interval. These are the critical Z scores we would be using. And then you multiply by the standard error to get us how wide we want our confidence interval. But we use percentile, two-tailed, because I want to say the lower bound and upper bound, and 92 is the central probability. Again, that's different than lower and upper tails, which we've done in the past, but we're doing two tail because I'm looking for the center.